Hello guys, welcome to my channel. And you asked for it, so here it is, the code. Over the last 5 videos, we covered RAG theory, what it is, how chunking works, hybrid search, re-ranking evaluation, agentic RAG, but the number one comment I'm getting is, show me the code. So today we are building a complete RAG pipeline from scratch, not a toy demo, 5 production ready levels, each building on the last. To show you the 5 level roadmap, here's what we are building. So the level 1, which is a basic RAG, okay, that loads, chunks, embeds, retrieves the answer. Level 2 is a hybrid search, vector plus BM25 keyword matching. Level 3 is re-ranking. So we add re-ranking and a cross-encoder picks up the best chunks. And fourth level is agentic RAG. So the system thinks, searches, evaluates, refines, and loops. And fifth is the evaluation. Okay, in evaluation, the RAGA score for all the 4 levels side by side we keep to compare. So by the end of this, you will have a GitHub repo that you can clone, run, and adapt for your own projects. So let's go. So quick look at the 5 structures. There are 5 Python files. Okay, one per level, plus a helper file that generates the data. Everything is self-contained. So let's start with the setup. So first, if you want to create a virtual environment, you can simply click on Ctrl+Shift+P and then type create environment. You'll see when you click on this, you have the VNV or Conda option. So click on VNV and choose the Python version. As I've already created, so I will not be moving ahead with this. Okay, now let me open the terminal. Okay, the VNV virtual environment is activated. So I will just do pip install requirements.txt. For me, it is already installed, so that's why it is satisfied. Okay, so to show you what are the requirements, there is the LangChain, okay, community Lang core, LangChain core. So that's our framework. And LangChain OpenAI, we are using for the embeddings and the LLMs. Okay, and ChromaDB we are using. So it is our vector store that runs locally, no Docker needed. Okay, and next is the rank BM25 for the keyword search in level 2. Next comes the sentence transformer. Okay, for the free cross-encoder re-ranking in the level 3. And the LangGraph for agentic loop in level 4. Okay. And RAGAS is for the evaluation in the level 5. Yeah. So now you would need a see the .env example. For this, you need an API key, OpenAI. Okay, you can copy the .env.example to .env and paste your key, and that's it. Cohere here is optional. We have a free fallback for re-ranking. Now let's create our test document. The script generates a fake company handbook. Let me show you this. Let me minimize. So as you can see, there's a function called create handbook that creates this. Okay. So it has all the remote work policies, expense rules, travel policies, leave policies, IT security. So I designed this document specifically to break the basic RAG. So it has policies like E401 that needs exact matching. It has dollar amount like $150 for client dinners, and it has a comparison friendly content. So domestic versus international travel is there. Okay, where the information is spread across different sections. Okay. So it is about 9,000 characters with 6 chapters, perfect size for our tutorial. Data blank. Let me run it. Now I'm generating it. Okay, it got generated. Now you can see this company. It's everything is there, the whole document. Okay. Now let's go to the first level, that is basic RAG. Okay. So the level 1 is the simplest possible RAG pipeline with 5 steps. Step 1 is to load. Okay, we are importing everything and loading here. So as you can see, we are loading it. Okay, the text loader reads the handbook into the LangChain document object. So one file, one document. Okay. So next step is we are doing chunking. Okay, here recursive character text splitter, okay, is being used. Okay, it has 5 characters per chunk, 50 chapters overlap. Why 500? Because it is small enough that each chunk is about one policy section. So that's why we are using 500. Then the overlap prevents the cutting of the sentence in the half at the boundaries. So the separator list tells to prefer the splitting on double new lines first, then single new lines, then periods, then spaces. So it tries to keep the paragraph intact. That is why these separators we are using here. So next comes the embedded plus store. Okay, so here we are using OpenAI text embedding 3 small model, converts each chunk into vectors. Next comes the ChromaDB stores them locally. Okay, there's no server, no Docker, just a folder on a disk. Okay, next is the retriever. So we create a retriever that returns the top 5 most similar chunks for any query. Okay, that's pure vector similarity, cosine distance we are calculating. Okay, so here you can see the retriever. Yeah. So next comes this RAG chain. So this is the modern LangChain way. Okay, like a LCL, LangChain expression language, you can say. Okay, so the chain takes a question, retrieves the context, okay, then formats it into a prompt, then send it to the GPT-4o mini. Okay, and paraphrases the output. So 4 line of code just. Okay, see, here embedding happened, here vector is stored, then the RAG chain here you can see. Okay, we are sending it to GPT-4o mini. Temperature is 0 so that it doesn't hallucinate, doesn't be more creative. Okay, so here there is a prompt which has a context question answer. Okay, then we format the docs also here. Okay, these are the test questions to test upon how much better the retrieving and everything is happening. Okay, now we are just running it. Let's see. So now let's run this basic RAG. Okay. So see here loaded, then it is chunking, then creating the embeddings, then building the RAG chain. RAG chain is ready. Now testing the each question. So for the question one, you can see, let me scroll up. Yeah. So the remote work policy works fine. So the answer is correct and detailed. See, every dollar and everything is matching. You will also cross check with the company handbook. Okay. Next comes this question two. What is the expense limit for the client dinner? So here we get, see here meals is $75, instance is $25. So it is properly giving all the possible limits for each. Okay. Now let's go to the question 3, which is what is this policy E401? So it is saying I don't have enough information. Why? Because E401 is a code, a keyword. A vector search looks for a semantic similarity. And the embedding for E401 doesn't land near the chunk. Okay, about the travel, reimbursement, etc. So the vector don't know that E401 is a policy code. So this is where the RAG breaks. Okay. And you can see this question 4, it gave correct. Now question 5, you can see here. Okay. So it says it doesn't have proper information completely. Okay. So these are things where it breaks. Okay. Sometimes it gives correct answer, sometimes it doesn't. Okay. Now let's move on to the level 2, which is the hybrid search. Okay. Let me explain the code a bit. Now this level 2 adds one thing, keyword search alongside the vector search. Okay. So it has the same loader, same chunker. Okay. I am skipping those things. Okay, directly jumping to the BM25 part. See here. Here is the BM25 retriever from LangChain community. So BM25 is the algorithm behind the traditional search engines. Okay, it counts the word frequency and matches the exact terms. So where vector understands the meaning, BM25 understands the spelling. So here what's new? Let me tell you what's new. Because the scores of cosine similarity and BM25 is in different range, we have to bring them in the same range, for which we use reciprocal rank fusion. Okay, now we need to combine the results of both retrievers. So we use this RRF. Okay, this is what the ensemble retrievers does internally, but we implement it ourselves in helper.py for maximum compatibility. Okay. So RRF works like this. So each retriever ranks its results. Okay, a document rank 1 gets a high score, document rank 5 gets a lower score. Okay, we add those scores across both retrievers, weight them 50 by 50 and resort. So documents that both retrievers agree on, okay, float on the top. So here the hybrid search function is there. Okay, it runs both the retrievers, calls the RRF and returns the top 5 merged results. Okay. So let me run this also once. Yeah. The everything is same, like the prompt creation and all. After this, everything is same, but just the hybrid search part is different here. Okay. So now let me scroll up. So this was the basic wrap complete. Yeah, this one. So same thing happens here. BM25 retriever is the additional. Okay, now we are testing the hybrid search. Now it is actually giving the exact keywords match also properly. Okay. So here E401, you can see it is able to connect with the travel reimbursement process. Now it is able to find that it's not saying that I don't have enough information and all. Okay. So it works that BM25 matches the exact E401 in the document. Okay, vector search missed it, but a keyword search caught it. So this is the hybrid search. BM25 catches what vector misses. But we are still sending 5 chunks to LLM and not all of them are equally relevant. Okay, some are noise. Okay, that's what re-ranking fix. Okay, whatever the chunk may not be everything may not be aligned with whatever the question is. Okay, so we are creating noise. So to prevent this, now we are introducing re-ranking. So let's in the level 3 add a second stage filter, a cross encoder re-ranker. Wait, let me scroll down. The hybrid search and everything is same, but here we are adding the cross encoder re-rank. Okay. So I'm skipping this repeated code above. Okay. Everything is same. Okay. Reciprocal fusion and all everything. Okay. Now there are 2 stages of pipeline. Okay. First stage is hybrid search that retrieves the top 10 candidates. Okay. That's the wide retrieval. Okay. Cast in a big net. In stage 2, we are using the cross encoder model to read each query chunk, pair, and score them. Okay. We keep only the top 3. That's the tight re-ranking. See, we are using here Cohere. Okay. If the Cohere API key we are not getting, okay, then we can use this one. Okay, it falls back to the cross encoder. Okay. And everything is same, like all the prompt creation, the questions and everything. Okay. Now let's run this. Okay, it is setting up. So meanwhile, let me explain you what is the difference between Cohere versus this free encoder. Okay. So the code auto detects a Cohere API key. If you have that, then it uses the Cohere re-rank v3.5. Okay, which is the best quality. If not, it falls back to the free open source cross encoder model, that is MS Macro Mini LM L6v2. Okay, good enough for prototyping with zero cost. So we also add this metadata enrichment here. Okay, like the source file. Okay, and let me show it to you. Where is it? Yeah, you can see here. So here we add the source file and chunk ID. Okay, this enables the citations in the answer. So the prompt now asks the LLM to cite a specific policy ID when available. Okay, now it has run. So let me scroll up till the question one. Okay, let me make it big. Uh, So here you can see the source is there and the top three chunks are re-ranked chunks are shown. See, in this way we can actually find the audit trail also. Okay, and all three are directly relevant to it. Okay, the noise is removed. So we can compare that to the level one's 5 chunks. Okay, where some were noises. Okay, so the LLM now gets a cleaner, more focused context, which means better answers. And the answer now include the policy ID like EX201, TR301, etc. etc. Okay. Also, let me scroll down. Yeah. See. So 3 levels are done now. So we have gone from basic vector search to hybrid search with re-ranking. But for truly complex questions, one that needs information from multiple sections, we need a system to think. So that's the level 4. In the level 4, which is the agentic RAG, let me show you. Okay, let's cross this. Okay. So this is where it gets exciting. Okay, we are building an agent that doesn't just retrieve, it thinks. So the problem with the level 1 to 3 is every level so far does only one retrieval and one generation. Like ask a question, get chunks, generate answer, that's all. Okay, but what if the question needs information from two different sections? Like compare the domestic and international travel. Okay, one search might find domestic but miss international. Okay, levels 1 to 3. Okay, just work with the whatever they got. But in this case, it's not like that. Okay, the first thing is we define the agent state. See the loader, everything is same. Okay, hybrid search coheres we are kept same. Oh, just a second. See here we are defining the agent state. Okay, so we define the what agent should remember. Okay, like agent state is a type dict. Okay, with the original question. Okay, the currency which changes, which we can change. Okay, and accumulated context, the answer, iteration count, max iteration set to 3 currently. Okay, and whether the context is sufficient and a reasoning log. Okay, so there are 4 nodes here. One is the retrieve. Okay, here we are passing the agent state. See. Okay, so here this retrieve calls our hybrid search plus re-ranker from the level 3. But here's the key difference. It accumulates the context. Okay, each retrieval adds to what we already have and we duplicate. Okay, so across multiple loops, the agent builds up a richer context. Understood? So here the iteration is there. Okay, and with the state we are updating the iteration, here the query, and we are printing the iteration with the what query we are retrieving. Okay, then we are calling this re-rank doc. Okay, new context is there, then all context is there. Okay, seen or not, we are set, we are using, and unique. Okay, then state is context, iteration, and reasoning we are updating. Okay, in this appending we are printing the length of the new context. Okay, and we're returning the state. Next comes this evaluate the context. Okay, so this is the brain. We ask the LLM a meta question. Give this question and this context. Do you have enough information to fully answer given this question and this context? Okay. If not, what's missing? It responds with the sufficient yes or no and describes the gap. Okay. So here you can see you are evaluating whether the retrieved context contains enough information to fully answer the user's question. Here we passing the question, retrieved context, respond in this exact format we are keeping, sufficient yes or no. Okay. And if there is anything missing, we can say here it is missing. Okay, it will say no, nothing is missing or not, like that. Okay. So if it is sufficient, sufficient is yes, then here we are passing is sufficient that variable. If not sufficient, then missing response. Then we are reasoning again. Okay. This is our brain. Okay. Now here it is the refined query node. Okay. If the context is insufficient, we rewrite the search query. We tell the LLM, here's what we already have. Here's the original question. Write a new query that targets what's missing. So if we found domestic travel info but not international, the refined query will specifically target to international travel policies. Got it? Next node is the generate answer. Once sufficient or after 3 iteration max, we generate the final answer using all the accumulated context. So in case of LangGraph, okay, writing basically the state graph from LangGraph has 4 nodes wired with edges. So the key is the conditional edge from evaluate. So if sufficient, if it is insufficient and under max iteration, go to refine. Okay, otherwise go to generate. That's the loop. So flow is like retrieve, evaluate, refine, retrieve, evaluate 3 times. Then if it is fine before only it will generate. If not, it will wait. Got it? Yeah. So now let me scroll you. Here is the just ask agent. Okay, we are just invoking that agent. Okay. Now we are printing with the questions. Where is it? Yeah. So here you can see the question 3. Compare the domestic and international travel, including per diem, rates, hotel limits, and approval requirements. Okay. This is the question 3. So let me run this once to make you understand. See. It says it is sufficient and then gives a final answer because it is straightforward question. Next, the E policy. First is insufficient. Then we are refining it. Okay, then retrieving everything. Then again it is missing. Then we are retrieving again and then generating the final answer. See, here the reasoning log is also there. Like iteration retrieved 5 chunks. Okay, then evaluation missed. Then refined again. Then refined again. Okay. The retrieve context does not provide any specific information. So it generates the final answer. So the 3 retrieval stats is there, 7 unique chunks were retrieved in total. Everything is showing, correct? In the question 3, it is again 3 times we are seeing that it is insufficient. Okay, so we will retrieve again. So in the iteration 1, the agent retrieves the 5 chunks, evaluates insufficient. It found the domestic travel but missing the international travel. It refines the query to specifically targeted international travel policies. Okay, then in iteration 2, it retrieves more chunks with refined queries, evaluates again. Now it has both domestic and international data. Okay, so the final answer is complete structured comparison with per diem rates, hotel limits, and approval requirements for both domestic and international travel. Okay, with policy IDs also cited, as you can see here. See, it includes everything, hotel limits and everything for domestic and international. Okay, reasoning log also can see everything is there, right? So the final answer is a complete structured comparison, as you can see here. Okay, that is something no other level could do. Okay, the agent searched multiple times, targeted what was missing, and delivered a complete answer. Also notice the one question 145. Okay, so like in the 4, 5, you can see the agent found everything in one retrieval and went straight to the generate. Okay, it is efficient when it can be. Okay, persistent when it needs to be. Got it? Next is the level 5. Okay, which is the evaluation. So let me first explain this. So this is where we prove it with numbers, not vibes. Okay. This file builds all four level from scratch, basic, hybrid, re-rank, and agentic, runs the same question through each one, and then scores them all with RAGAS. Okay. So here there is a evaluation data set that has been used. Okay, which has 5 questions with the ground truth. Okay, there are same questions we have been testing, but now with expected answers, so RAGAS can measure accuracy. Okay, so here everything that we have already seen is there. Now we are going to the questions. Just a second. See, here is the evaluation data set with the ground truth, what we are expecting to find. Okay, so that we can evaluate better. So there are three RAGAS matrix. One is context recall. Okay, did we retrieve the right chunk? Were the relevant documents actually in the what we pulled back? Second is faithfulness. Is the answer grounded in the context or is the LLM hallucinating? Third is factual correctness. Does the answer match the ground truth? If you're not measuring, you're guessing. So RAGAS give you the numbers. So the evaluation uses a free cross-encoder for re-ranking. Okay, just for note. Meanwhile, I'll be running this. Yeah, let me scroll down. Okay, now I'll be running this. So a note on cost and time. Okay, the evaluation uses a free cross-encoder for re-ranking. No Cohere needed. Okay, it forces to use Cohere as false to avoid the rate limit on trial keys. Okay. So the whole evaluation takes about 5 minutes and cost a few cents in OpenAI API key calls. Okay. So as it is running now, okay, it is evaluating everything. Let's see. Yep. So here it says all four levels are ready. Okay, evaluating data set is there, running the questions through all the four pipelines. Okay, one by one. Okay, now the RAGAS. See here, there's basic, hybrid, re-rank, all the answers, how it came, it shows up. Okay, based on all these 5 questions, it is now evaluating. So first it builds all the four levels, then runs the questions through each one. Then you can see side by side comparison in the terminal. So let just wait for completing. So now you can see here it is evaluating everything. Okay, found the faithfulness, context recall, factual correctness also. And here the money shot. Okay, so the full comparison table, all four levels, three metrics scored by RAGAS. Okay, so look at the progression. Context recall improves from basic to hybrid. So that's BM25 finding what vector missed. Okay, see. Next is the faithfulness improved with agentic because the agent accumulates better context. Right? Okay, next is the factual correctness. Okay, it is the highest for agentic as more context means more accurate answers in this case. So the table is the proof that each upgrade matters. Screenshot it, put it in your README. Okay. If you want to publish it in your GitHub also, okay, you can use it directly. So let's recap what we built today. So the level 1, which is the basic RAG, okay, it has 20 lines of core code, okay, works for simple questions but breaks on keyword and comparison. Level 2 is the hybrid search that added BM25 keyword matching and reciprocal rank fusion, okay, so it fixed the keyword queries like policy codes and all. Next comes the re-ranking that added a cross-encoder that filters to the only the top 3 most relevant chunks, better precision, better answers. Next came the level 4, which is Agentic RAG. Okay, a Lang agent that thinks, evaluates, refines its queries, and loops until it completes the information. So this handles the complex multi-part questions. The level 5 was evaluating all the 4 levels. Okay, so we use RAGAS scores across all 4 levels, proving that each upgrade delivered measurable improvement. So the full code is in GitHub and the link is in description. Or clone it, run it, adapt it for your own data. Okay, so this is the final video in our RAG series. If you watched all the 6, you now understand RAG. Okay, from theory to production code. If you found this helpful, hit subscribe. I'm going deep dive on AI engineering topics and there's a lot more coming. Okay, always remember, start simple, measure, upgrade one layer at a time. See you in the next one. Bye.